Hello, everybody. This is Mr. Palamine, your 7th grade through 12th grade instructional coordinator for math. Um, I'm going to be going over solving two-step linear equations and inequalities. Um, and there's quite a few videos going to be in this one here. Seems like close to 20, right? And so I'm going to walk you through how to solve these problems with algebra tiles, different versions of tiles, balance, all this stuff here. So this is all from state release assessments. And then how we go from these tiles to not using the tiles maybe, and how the numbers get bigger but still maybe using some kind of picture. This one, again, can we use a picture? Not use a picture? I don't know, probably not. And then inequality. So this up here will say inequalities, right? But anyways, you're gonna see these little videos are gonna be like right here. Just press click, watch them. I'm making the YouTube videos public for anybody to watch. I'm sharing some numbers here to just get you know how we did. So I'm gonna go ahead and start with a very straightforward one that's modeling all positive tiles. I'm gonna be using a website called Polypad, and you'll see how we go from this to these answers here. Um, so if you're a math teacher watching this, this is where you bring out the tiles, right? And this is how we did as a state back in 2023. We did, not the state did 47%. We beat the state at a 64%. So 6 out of 10 of our kids got the right answer, or 64 out of 100 of our kids got the right answer. I think we can do better than that, and then show you how. If we introduce the tiles to our students, man, we're gonna ace anything that is this standard, which is 7-11-8, by the way. But again, I don't want to go into standards here. This is just, let's get to the math here. What does this mean? Well, this means x. So I'm going to go here. I can see 3 of the x's. So I'm going to go to my Polypad. And I'm going to bring out 3 of my x's. 1, 2, 3. Right? So that's what we got right here. 3 x's. Get it? That's exactly what's here. And then this little guy on this side's a 1. Bam, right there. We have an equal sign here. Now, what we do with the Polypad, we don't put the equal sign. We're going to put a little line. And this line's going to kind of separate everything. So this is our equal sign. So this side equals this side on the right. Well, I see 7. 1, 2, 3, 4, 5, 6, 7, because these little guys equals a 1. So there's 7 of them, so that's 7. So I'm going to come over here. I'm going to go like this. I'm using Polypad, so it's a virtual website, and it's free. So I'm hoping you guys use it too. Now I'm using a pen off something called a Wacom. So I'm going to set everything up. So this is how we do it with the tiles. And all you gotta do is stop the video whenever you want, ask questions whenever you want, go ask your teacher, hey, what did this guy do, that kind of stuff. It's real simple. I want, for my case at least, I want x on the left side. I only want x here and everybody else on the right side. And I'll show you what I mean by that. All right, so this is what we're gonna do. I need to get rid of this +1. So you just don't remove it, all right? I need to put something here that gets rid of it. That's going to negate it, right? That's going to zero it out. Well, I'm going to bring this -1 over to this side. And so here's the thing, though. Since I'm going to add a -1 to this side of the equation, it kind of gets everything off whack. So here's the deal. Let's say, for example, these are my I got some weights right here. And on this side, I have, 5 pounds. Let's see if I got any numbers here. Let's see here, number frames, number bars. Yeah, let's say, for example, I got 3 pounds on this side, and I got 3 pounds on this side. But I decide to remove, let's go like this. I got 4 pounds on this side, let's go 4 pounds on this side. If I take off a pound, what happens now? Well, I got 3 on this side, 4 on this side. So in order for me to keep everything balanced, if I remove 1, I got to remove the same value on the other side. So it keeps the weights balanced. I don't know if I have a balance beam here or not. Let's see here. No, I don't. But if I did, I'd show you what I mean by that. There's no balance beam. So some other websites have the balance beam so you can kind of see it. So in this case, just think of this as weights, right? So if I remove 1 pound on this side, I got to remove 1 pound from this side. If I can break this guy apart, it'd be the same thing. If I remove 3 on this side, I better remove 3 on this side. Let's say I got 3 here and I got 3 here, and I add a pound. Well, I better add a pound on this side to keep everything balanced. Is that making sense? Good. So that's the gist of what we're doing there, right? So I am going to put a -1 on this side. But since I got -1 there, I better put the same -1 on this side to keep everything balanced. So what happens here? It zeroes out, and this zeroes out. So I removed one from each side. So we get you out of there, and get you out of there. We'll delete you. The next move is I got to evenly distribute all those numbers on the right hand side with one of these X's. So it's like you're going to share, right? I got 3 people, I got 6 things. So hey, you get one, 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 you get one. That's it. So X equals 2. 2. And that should be my answer over here. C. Was that C over here? Yes, it was. So my answer was C. You see how easy that really was? How easy that is. But only 6 out of 10 of our kids got the right answer. If we use the tiles, we'll get more than 6 out of 10. This number will be pushing maybe 80 or 90%. But we got to bring out the tiles. You don't bring out the tiles, our kids are going to stay lost. You know, it's like we got a D, really. So I prefer an 80 or a 90% correct on this one. So as your math coordinator, please use the tiles, right? If you choose not to use the tiles, explain to your principal why you don't want to use them. But I'm telling you right now, we need to use them. This is from the state test, by the way. This is a STAR test, and they're using the tiles. Maybe we should too. So I'm going to give you a pictorial representation. 1, 2, 3. I'm going to use a circle for my 1. And over here was 7. All right, this is concrete. This is a picture. Then over here, I'm going to call something called an A, abstract. I could use an S, it's called symbolic. So let me show you what's really happening here. I got 3x plus 1 equals 7. When I added that -1, I also added that same -1 to both sides. All right, so I canceled this guy and I canceled these two. This is what I did. I subtracted 1 on both sides. Now I bring down that 3x. 7 minus 1 is 6. I have 3x equals to 6. I got 3x equals to 6. And then I can draw my x's like this, by the way, laying down, right, horizontal. And I can say, okay, 1, 2, 3. 1, 2, 3. You guys are good. And these guys canceled out already, right? 1, 2, 3. 1, 2, 3. I did what's I modeled division, right? I literally modeled division. I got 3 divided by, I got 6 divided by 3, and then each person gets 2. We actually do that kind of division in 2nd grade. So if you're a student watching this, you did this as a 2nd grader. You might not remember, but you did. We write it like this. I'm going to divide both sides by 3. When I do it one side, I got to do the other. So if I divide by 3 on one side, I got to divide by 3 on the other. These 3's do not cancel out. They equal to 1. They don't zero out. They equal to 1. So x equals 2. What is 6 divided by 3? 2. All right, so too many times we'll have teachers that just show us from what this means, and they want the students to write it this way without going through the process of why it works. We have to go through the process of going concrete to the picture to the abstract so our kids can see it. In other words, they should be able to see this problem and immediately give me an answer like that because they got used to using the tiles, at least pictorial representation of the tiles. In other words, so they should be able to, at this point in time, see this, right? And go, let's see if it's right on the pin. Oh, look, check it out. This guy's gone. This guy is gone. I got 1, 2, 3. 1, 2, 3. And then each one gets 1, 2, 3. 1, 2, 3, right? So each one gets 2, right? 1, 2, 1, 2, 1, 2. I divided by 3. So x equals to 2. And that's it. But if you don't go through this process of you actually using the tiles and going from the concrete to the picture to abstract, they won't do what I just did right now, right? So I hope we start using the tiles. They're a wonderful tool to help our kids get better at solving for a letter and conceptually understand this before we can move on to any procedure or skill. If you're a student watching this, hope this works. The video works. I know it's a little long, but the introduction one goes pretty slow, and then from here on the rest of the video should speed up.